Okay. Determination of molecular weight by osmotic pressure. This method, also known as osmometry, which is used to determine the number average molecular weight of polymer. This method is based on the phenomena of osmosis. If pure solvent is saturated from a solution through semi-permeable membrane due to concentration difference between the solvent and solution, the solution will flow into the solution through semi-permeable membrane. The pressure applied on the solution to completely stop the flow of solvent into it through semi-permeable membrane is called osmotic pressure. The theory of osmotic pressure also applies to a solution of polymers. Ordinary solution obeys Bantoff's equation pi equals CRT over M, where R gas constant, T temperature, M molecular weight, C concentration. The polymer solution is non-ideal, taking into the account their deviation and using thermodynamics, mammalian and Mayer modified Bantoff's equation for polymers pi equal to CRT over M plus BC squared plus DC cube divided by C on both sides. We get lambda over C, CRT over T, MXC plus BC plus DC squared. So lambda over C equal to RT over M BC plus DC squared. For dilute polymers, solution concentration is small, DC squared, small negligible, pi over C equal to RT over M plus BC, Y equal to MX plus C. If the graph is plotted, lambda over C versus C, we get a straight line having a slope B and the intercept RT over M. Lambda over C, RT over M slope, MX plus C. Light scattering methods. The molecular weight of high polymers in solution can be determined by measuring the intensity of light scattered by them. If a non-absorbing light is passed through a substance, nearly all of it is transmitted and a very small fraction of it is scattered in a direction, in all directions. See, I naught scattered, this is the IT transmitted. The scattering of light, known as the Wave-like scattering due to interaction of oscillating electric field of the incident light with the particles of the medium. The frequency of the scattered light is equal to that of the incident light. The intensity of scattered light is given by I is equal to I naught minus IT. Due to big size of molecule in solution, turbidity is produced. Turbidity is defined as the fraction of turbidity is defined as the fraction of the incident light scattered by the solution per cm length through which the light passes. The turbidity T is given by IT equal to I naught E minus TL. Turbidity increases with increase in the concentration as well as molecular weight. Debye showed that turbidity of a solution is related to molecular weight of the polymer by expression C over T equal to I over M plus 2Bc. B is the second biennial coefficient. The turbidity C is the concentration of the polymer in gram per 100 ml is constant for a given polymer and given dispersion medium, a molecular weight of polymer. The value of H is given by the expression H equal to 3 pi square n square dn over d square over 3n pi lambda 4, where n is the refractive index of the dispersion medium, lambda wavelength of the light is used, dn over dc is the variation of the refractive index with concentration. If we plot a graph between the lambda c over t, b versus c, we get a straight line which is extrapolated to 0. Concentration gives the intercept equal to 1 over m can be calculated molecular weight by T. A limit C tends to 0, H over T equal to 1 over m, H over T equal to 1 over m plus 2Bc, Hc over T versus C intercept 1 over m. This curve is called Gibbs curve. To find out the molecular weight of the high polymer in solution, it is necessary to find out the turbidity of the solution at several concentrations of the solution. Turbidity can be determined by measuring the decrease in the intensity of the transmitted light. Limitation. This method gives the wrong result at molecular weight m above 10 lakh. Dust particles also scatter light. Okay. This method gives the wrong results for molecular weights above 10 lakhs because those particles also scatter light, causing the problems in the wrong results. Viscosity measure methods. Viscosity is the measurement of a fluid's resistance to flow. It describes the internal friction of the moving fluid. A fluid with large viscosity resists motion because its molecular makeup gives it a plot of internal friction. A fluid with low viscosity flows easily because its molecular makeup results in a very little friction. When it is in motion, it is a simple method for determining the molecular weight of polymer. Addition of polymers in solvent increases the viscosity of the solvent due to increased intermolecular forces at same temperature. Viscosity of pure solvent, neta naught, viscosity of solution, neta. Relative viscosity refers to the ratio of the viscosity of polymer solution to the viscosity of the solvent. So, neta R equal to neta naught over neta naught. Specific viscosity is defined as relative increase in the viscosity. So, neta specific is neta minus neta naught over neta naught. So, we can write neta over neta naught minus 1. Reduced viscosity is defined as relative increase in the viscosity per unit concentration C polymers, neta reduced equal to neta specific over C. Intrinsic viscosity, C tends to 0, limit C tends to 0, neta specific over C. The reduced viscosity depends on the concentration C. When the graph is plotted between the reduced viscosity and concentration, the extra plotted value T equal to 0 is called intrinsic viscosity. Thus, the value of intrinsic viscosity can be known easily from the value of the reduced viscosity. Stern-Dinger gives the relation between intrinsic viscosity and polymer and molecular weight of polymer, neta I equal to Kma. If the value of K and are known, the molecular weight of the polymer can easily determine.